In this video, I want to sort of give you a background information on imaginary numbers. And so first, think about number one. Let me give you a number line, short number line over here. And this is 0, this is 1 right here. There's a few things I could do to this number 1. I can multiply by -1, for example. If I multiply 1 by -1, that will give me a -1. That will kind of, on the number line, it will be on this side. So if you think of this in geometric terms, it looks, it is really like rotating this little segment right here by 180 degrees counterclockwise. So multiplying by a -1 is a rotation by 180 degrees counterclockwise. If I multiply again by -1, another -1, I will get to 1. So it's another rotation by 180 degrees. So I can continue multiplying by -1. I'll just keep rotating 180 degrees each time. All right, so similarly, is there any such number by which we can multiply 1 by, let's go over here, that will rotate it by 90 degrees? That's a question that we're going to explore. We want to try to multiply 1, the number 1, by some number that will result in a rotation by 90 degrees. That will be a rotation by 90 degrees. Okay, so mathematicians have invented this kind of number. That number is called I. It's an imaginary number. So you have to imagine a vertical axis that is perpendicular to the real number axis. So here is the real number axis. Here is the real number axis right here. So when we rotate a given number, like say 1, number 1, by 90 degrees, so we're going to be rotating to another axis. That axis is an imaginary axis. So, and then we're going to end up with 1 times imaginary number I will give me I over here. It's hard to comprehend until you begin to use the number, because imaginary number is actually really useful in other fields, like in engineering, really useful. So for right now, you have to take it on the face value that I multiplied by I really means that we are rotating a number 90 degrees from the real axis. So let's do some exploration with that said. Let's do some exploration. So if we start with 1, and so there is just 1. All right, we just start with 1, and then just 1, and then 1 to the power of 0. So imaginary number to the power of 0 is 1. So now if we multiply by 1, I times 1 is just I, imaginary I. So, and that will be I to the power of 1 is the same. If I multiply by another I, so I am going to rotate one more 90 degrees one more time. That will be a total of 180 degrees. So that will land at -1. So I times I is a double rotation through 90 degrees. So I times I really is a -1 is the answer, is the result. And that is written as I squared because it's a double rotation through 90 degrees counterclockwise. If I continue to multiply by, rotate this number again by another I, so that means I'm going to multiply the -1 times I, -1 times I will give me -I. So I just take that -1 and then rotate another 90 degrees back here will be negative I. And so triple rotation by 90 degrees will end up at negative I. That's the triple rotation right there. So triple rotation will give me a negative I. And then that it can be written like I to the power of 3, showing we are multiplying I by itself 3 times. And now we can continue the process and rotate one more time by 90 degrees. That will take me back to 1. So get me back to 1. So unlike the multiplication by -1 that requires double multiplication to get back to 1, we need to multiply or to rotate 90 degrees 4 times to get back to 1. So we need to rotate 4 times. So we can continue the process and continue through by multiplying by another I again. We get us back to I. So it will be I again, and that's I to the power of 5, and so on. We can multiply one more time by another I will get me back to -1, and that's I to the 6th. So we can see the cyclical nature of this multiplication, that we just go around rotating this number 1 through I, -1, -I, and back to 1. And we can see the process there by what the value is cycled through 4 different values: 1, I, -1, and -I, and then back to 1. So actually I can do I to the 7th. I can project that to be -I, and then I to the 8th. This way, sorry, that will be 1. I to the 8th will give me 1. So basically there are these four values that we can get by going through the process. These 4 values right here: 1, I, -1, -I, and then back to 1. So we can use this pattern really to explore the other powers of I. There are other powers of I in these examples over here. So if I want to know what's going to be the value of I to the power of 11, all I need to do is, make a little sketch of the axis, the real axis and the imaginary axis, and then think about how many times I have to go around until I get to 1. So 4 rotations will get me to 1. All right, if I do another 4 rotations, will get me to 1 again. So I to the 4th will be 1. I to the 8th will be 1. I to the 12th will be 1. So all these exponents with the multiples of 4 will get me to 1. But we see that 11, I to the 11, this 11 is 1 less than 12. So it's 1 rotation short of 1. So that means that it's going to be at -I, because it's 1 rotation short. So that will be -I. Now, if you continue with the same reasoning, we know that 4 rotation will get me to I to the power of 16 back to 1. 13 rotation will get me 1 more than the 1. I mean, 1 rotation more than 1. So we're already at 1 at I to the 12th. And I to the 13 will get me to I again. So I'm going to go to I. I will get to I. I'll get to I. I to the 18th, that will be 2 more rotations from I from 1, that will be -1. -1. 24 is a multiple of 4, so that will give me 1. 19 is 1 less than a multiple of 4, 1 less than 20. So that will give me -I. And then 27 is 1 less than 28. That's also -I. 19 is 1 less, so we already have 19, so there's just this 1 less, 1 negative, so -I. 31 is 1 less than 32, that's -I. 30 is 2 more than 28. So 28 is I to the 28 is 1, I to the 29 is I to the 38 will be -1. So that will be -1. 36 is a multiple of 4, that's 1. 39 is 1 less than 40, -I. 43 is 3 is 1 less than 44, that's -I. 45 is 1 more than 44, that will be I. 59 is 1 less than 60, -I. 65 is 1 more than 64, that's I. 72 is a multiple of 4, and that will be 1. 89, so we know that 80, 84, 88. So 89 is 1 more than 88, that will be I. 93, so 88, 92. 93 is 1 more than 92, that will be I. 150, so let's think about that for a little bit. So what is the closest power of 4 or multiple of 4 to 150? If you divide 150 by 4, you're going to get a decimal. So it's an even number that is not a multiple of 4. That's a -1. And then 310 is an even number. If you divide it by 4, it's also not a multiple of 4. So it must be -1. So the summary is that if the exponent is even, your answer will either be 1 or -1. It is 1 when it is when it is even and a multiple of 4 is 1. So it will be a multiple of 4. Otherwise, it's even, it's not a multiple of 4, it's a -1. If the exponent is odd, then it's either I or -I. So if it is 1 more than a multiple of 4, then it's I. If it's 1 less than a multiple of 4, then it's -I. That's basically how to figure out any power of I. Here is an extension of imaginary number to include real numbers. So complex number is really any number of this form, a plus bi, where a and b are real numbers and I is an imaginary number that we have been talking about. So here's an example of a complex number, 2 plus I. It has 2 parts. It has the real part. And then it has the imaginary part. So the real part can be plotted on the real number axis. That's the real number axis right here. And the imaginary number on the imaginary number axis, like this part in blue. So imaginary number will be this and the real number will be the yellow one, okay? Now, if I want to plot this number 2 plus I just need to locate 2 units on the real number line and then locate 1 unit up on the towards the imaginary part, and then put a locator there as a point there. That will be number A, 2 plus I. Similarly, 4 minus I will be, we go 4 units on the real number and then 1 unit down on the imaginary. That's my B. Negative 3 minus 4I will be 3 units to the left of 0 on the real number axis, and then 4 units down on the imaginary axis. That will be the number. That will be the other number, C. And then lastly, negative 2 plus 3I. So we'll go 2 units, negative 2 units on the real number, and then go 3 units up on the imaginary. That will be negative 2 plus 3I. Okay, so this one is negative 3 minus 4I. This one is 2 plus, sorry about that. That's my clock saying I should go to bed. And 4 minus I. This is 4 minus I. So basically, that's how to locate complex numbers on the complex plane. Hopefully, this is helpful.